Hello everyone, welcome to this lecture of the course Digital Electronics and Circuits. And in this particular lecture, I briefly wanted to touch upon setup time and hold time, which we discussed in the previous lecture. These are the notes from a previous lecture where we discussed flip-flops and we draw a basic flip-flop circuit. Then we went upon different kinds of flip-flops. And this is where we discussed about setup time and hold time, where we said whenever we change an clock value, keeping the input is equal to same, right? What happens is our input, our output is reflected, and that particular output will not change. Like if at all there's a one clock gate delay, right? And similarly we saw this situation of hold time for two scenarios when we have a value of d and clock change from 0 to 1. And here we saw the same situation whenever a input has a value of 1, clock change from 0 to 1. We saw that only the state s changed, and once the design was set to 1, and so basically after post that time d could change to any other value, and if clock is not toggling, our output will not change. That we called as a hold time. And setup time, how did we analyze this? We changed both input and clock at the same point of time, and at the end we got a wrong result. And we said this is not the right thing, because it means that the input d has to be stable for some clock cycles before the clock toggle happens for the output to be correct. And we discussed this to be two gate delays, right? So just to summarize this in layman terms, we have two terms called setup time and hold times. And to understand this concept, right, what we can do is we can draw a clock signal, which we say it's like getting a positive edge over here. And let's assume we had a signal called d, which is input, which is undeterministic for some time, right? And then it got a value, and let's assume it goes undeterministic post that time also, right? So based upon whatever we discussed for setup time and hold time, right, we would say that basically the time from here to here would be something like t setup. This would be t hold, correct? So hold time we discussed first. So hold time is nothing but it's a minimum time interval for which the input signal must be stable or unchanging following the sampling clock event, right? For the input signal to be recognized correctly and captured correctly. And this we spoke about was one gate delay in our previous example, right? Equal to one gate delay. So this is the whole time. It's the time for which the input D should not change once the positive edge of the clock has been triggered for it to get captured properly. And then similarly, right, we have a concept of setup time where we say that it's the minimum time interval for which the input signal must be stable before the clock edge appearing so that this signal is sampled properly. And as we saw for the previous example, this was equal to two gate delays. So hopefully this setup and hold times is much more clearer with this example, and we could see like how setup and hold times are related with respect to D and clock over here, if we have to look at in terms of the overall flop rather than looking at a gate level, right? At the top level, this is what setup and hold times would look like. Thank you.